So hi all, welcome to this another video lesson. So today we will see 608, that is tree node. This is a medium level problem. So in this problem we have a data set which is of type tree, okay, in which the column name is id and p underscore id. So id is a column with unique values for this table, and each row of this table contains information about the id of a node and the id of its parent node in a tree. The given structure is always a valid tree. So we have the leaf node, we have the root node and the inner node. So root node, it doesn't have any parent. It is like the topmost tree of node of the tree. Inner node is the node where which have it has your child nodes, but it also has a parent node. Okay, so inner node has both child nodes as well as parent nodes. Okay, and then there is leaf node which only have parent node but it does not have child nodes. Okay, so here in this example, if you just see, obviously 1 is our root node, 2 is our inner node, while 4, 5 and 3, they are our leaf nodes. You see 3 only has parent node, that is 1, but it does not have any child node. Similarly for 5 and 4, they only have parent node, that is 2, but they do not have any child node. And 1 is the root node because it only has child nodes but it doesn't have a parent node. And 2 is our inner node because it has 4 and 5 as its child node and 1 as its parent node. So we have been given this input in the form of a table. Okay, id and p underscore id. If you look into p underscore id, it is null 1122, correct? So we have to get this into the output. The type, what is the type of the id? So 1, it has null, so p underscore id stands for the parent. Because 1 does not have any parent, so it is null, and because it is null, that means it's of type root. 2 has a parent, that is 1. Okay, so 2 has the parent 1, so 2 is our inner. 3 on the other hand has the parent 1. Okay, but if you look at 4 and 5, right, 4 has the parent of 2, so that makes 2 as the parent node. But if you just see here in this set, in the p underscore id, 3 your 2 is not 3 is not present in p underscore id, so 3 cannot be taken as a inner node, it has to be taken as a leaf node. Okay, so one simple logic that I can really apply over here is, if first my logic will be that if your p underscore id is equals to null, so it is going to be our root node. And the second logic for the inner node will be that if my id lies inside this p underscore id, then definitely that will be my inner node, else it will be leaf node. Okay, so let us just start the query. So select id comma, now we are going to start with different cases. Okay, case when, let me bring this into the next line, when p underscore id is equals to is null, then it will be root. When id, if id lies within, now if id lies within p underscore id, that is select p underscore id, right, from tree. Okay, then what it will be, then it will be inner. Okay, and then over here it will be else it will be leaf. Okay, and then we can end this. And the type, let me alias this as type because it will accept it as type, from tree. That's it. So this looks correct. Let's run this. Okay, this has accepted. Let me submit this. Okay, this has a runtime of 620 milliseconds, beats 48.15. Let me submit this again. Okay, so now it has a runtime of 491 and a beats 71.04. So here you can see that it has a pretty good accuracy over here. So that's it, guys. I hope you have enjoyed this session. Then don't forget to like, share and subscribe my channel, and please don't forget to press the bell icon for notification. Thank you.